there is some parts of BGP is remaining, okay, to complete. We have seen BGP. We have almost completed all the things. Some of the parts are remaining. Some of the small topics are remaining, and these small topics are very important, like BGP attributes, how BGP will select the path, how path selection is done in BGP. Okay, BGP path selection process. So first we will see BGP attributes. Now BGP chooses a route to any network based on the attribute of its path. Okay, like we use, like the IGP protocol and the other routing protocol use metric values, this BGP will use attribute. Okay, so we have four categories of attribute. If I say four categories of attribute, we have well-known mandatory, we have well-known discretionary, we have optional transitive, and we have optional non-transitive. Okay, these all things we have already seen the synchronization. Now path selection. So I told you there are four types. So if I make a tree, I explain you with the tree. So here is BGP attributes. BGP attributes. Okay. Now BGP attributes are divided into two parts, two main parts. The first one is well-known and the second one is optional. Well-known and here is optional. Optional. Two main types of this is well-known and optional. Then in well-known, we have two types. Just give me a second. Then we have in well-known we have two types. Sorry. Well-known we have two types, mandatory and discretionary. What are the two types? Mandatory and discretionary. Discretionary, mandatory and discretionary. Okay, both are the two types. These are the two types. Sorry, the call was from office. Okay, so where was I? I was telling you that in well-known we have two types. We have discretionary and we have mandatory. Okay, then in optional we have two types in optional. The first one is transitive and the second one is non-transitive. transitive and non-transitive. Non-transitive. Okay, transitive and non-transitive. These are the main types of attributes. Okay, then if I come into subtypes, in mandatory, I have some subtypes. Like if I come in mandatory, I have 3 subtypes. The first one is AS path. AS path. AS path. So I have explained you what is AS path. Then next hop. Next hop. Then there is origin. Origin. Now origin is again divided into 3 parts. Origin is again divided into 3 parts. Origin means first one is I, then E. I'll explain you all these things, then question mark. These are in origin, I, E, and question mark. In discretionary, we have two. In discretionary, we have two. The first one is local preference, and the second one is atomic atomic aggregator. Atomic aggregator. Okay, then in transitive we have the first one is aggregator, second one is community. Now in community we have much more, and I'm not going in depth about the community thing. Okay, but we have many other things in community. Okay. Then in non-transitive, we have 3. Non-transitive, we have MED, and here we have originator, and here we have cluster ID. Okay, cluster ID. So these are this is the tree when I say the attributes for BGP. These are the attributes that BGP looks when it want to select the path. Understood? These are the attributes.
Just hold a minute. Done. Okay, that's
okay. Any questions still here? Okay, so these are the attributes that are used to select the path in BGP. Okay, these are known as BGP attributes. Okay, now well-known means well-known attributes. If I say well-known mandatory, as the name only says. See, now the attributes are divided in this way. Four categories: well-known mandatory and well-known discretionary. Then optional transitive and optional non-transitive. So well-known means they are well-known and they are mandatory. They must be there when you are when means if I'm saying well-known means must be recognized by all BGP routers. Okay, so this well-known mandatory will be present in all BGP updates and it will be passed on to other BGP router. Like if I say here well-known mandatory, AS path information will be there, next hop will be there, origin will be there. What is origin? I'll let you know. Okay, what's origin? I'll let you know. Now, well-known discretionary means must be recognized by all BGP routers and passed on to other BGP routers. Okay, but need not to be present in any update. So if I say well-known discretionary means uh, if it is not it must be recognized. It must be recognized by the like the local preference, atomic aggregator. These all things must be recognized by all BGP routers, and they must be passed on to other BGP routers. But it is not necessary that they will be present in the update. They will be present in a update. It is not necessary. Okay, so well-known discretionary are well-known attributes, but they are not present in need not to be present in any update, BGP update. And well-known mandatory means they are very well known and they need to be present in all the BGP updates. Understood? These are well known. Then we come to optional. Optional means might or might not be recognized. As the name only says, now as the name only says, optional might or might not be recognized by a BGP router, but is passed on to other routers. What it is done, it is passed to other routers. Okay, it is passed to other routers. Means if not recognized, it is marked, it will marked as partial. Like aggregator and community are two types of optional transitive attributes. Optional, these are optional, these are not mandatory, these are optional, might be and might not be recognized by the BGP router. Sometimes you will get, sometimes you will not get. Okay, understood? Then optional non-transitive. Optional non-transitive is something like if the BGP project does not recognize the attribute, that then it can ignore the update and not advertise the path to its peer. Okay, what will happen if the attribute is not recognized by the BGP? Okay, then it will ignore the update. It will ignore the update and it will never advertise it to the neighbor. Okay, MED, multi-exit discriminator and originator ID are the two type of. Now here we will at the CCNP level, we will be only studying about well-known mandatory and well-known well-known mandatory and well-known discretionary. Optional, we will not move to optional. Okay. Got it? Any doubt? Any question? Then we have AS path. As I told you, we will be going into well-known mandatory. So well-known mandatory, the first one is AS path. AS path is a BGP, you can say it is a well-known mandatory attribute and list of AS through which updates are traversed. If you remember, I have explained you previously that what is AS path. Suppose I am having one autonomous system over here, another autonomous system over here, and one autonomous system over here. And you can say one autonomous system over here. I can take it anywhere here. Now, if I connect this autonomous system in this way, okay, now this is suppose my AS number 65,111. This is my AS number 65,222. This is my AS number 65,333. This is my AS number 65,444. Okay, these are the autonomous system numbers, and I'm having different autonomous system numbers here. And suppose I'm having some 20 dot network over here, 20.2.2.0 network. Now, whenever this 20 dot network is advertised to other autonomous system, how it is advertised? It has been advertised in this way, that this update is coming from this 20.2.2. network is coming from AS 65444. This update is coming from 65444. Okay, got it. Now, when this 65333 is updating this information to other autonomous system, this 20 dot network, then how it will update? It will say this 20 dot network is 20.2.2.0 is coming from AS 65333 and it is originating from AS 65444. This is how it will advertise the 20.2.2. network. Now, when this 65222 will get the update, how it will advertise? It will say AS 65222. It is coming for, sorry, the 20 dot network is been is it is when it will send to 65111. How it will send? It will send that it is coming from 65222. Then it is coming from 65333 and it is originating from 65444. Understood? This is known as AS path. It will have the path information, like from where it is originating, from where which OS it is originating, then which OS it is going the next, then the next, and then the next. In this way, it will have the AS path information. Understood? AS path information. Now, path with the shortest AS path is list of more desirable. Path with the shortest path is more desirable. Okay. This is something my path attribute. Then what is the next attribute? The next attribute that we have seen in next hop. Now we have already seen what is next hop. The next hop attribute is well known mandatory. BGP is AS by AS routing protocol. Now next hop is not equal to next router over here. Next hop is equal to IP to reach the next autonomous system. You remember next hop? Okay. Now next hop behavior, next hop attribute. Now we have origin. Now we have three types of origin over here. Origin means the updates are coming, whatever updates I am receiving, what type of updates are they? In BGP, the updates like in OSPF, we see E1, E2 routes, we see N1, N2 routes, we see OIA routes. Same way, when I'm receiving any update in BGP, what type of update is it? What type of update it is? Either it is an I update, E update, or it is an question mark. So I means anything you advertised in BGP using the network command, it will show you I. It will show you as I. If you update anything in BGP with the network command, it will show you as I. On the neighbor side, it will show you as I. I. Okay. BGP network. E means uh, older version of BGP, that is EGP. Some routes that are, see that previously BGP was having an older version which is EGP. Okay, so EGP is something like the older version. Okay, so if any routes are redistributed from EGP inside BGP, then that type of routes will be seen as E routes. Question mark, if anything is redistributed into BGP from any of the IGP or static routing. If anything is redistributed into BGP from IGP or static routing, that is question mark. Understood? This is something my origin attribute. Any doubt? So if you want to see this origin attributes, you can give show IP BGP command. Okay, so you will see over there some of the path you will see I. Okay, if you redistribute anything, you will see question mark like this. Got it? Now we have weight attribute. Weight attribute. Weight is a Cisco attribute. Okay, Cisco's attribute means you will not have weight in any other vendor router. You will only have weight in Cisco's router. As weight is Cisco's attribute. Okay, what it will tell? It will tell us how to exit the autonomous system. What weight tells us? Weight will tell us how to exit the autonomous system. Okay, path with the highest weight is more desirable. Path with the highest weight is more desirable. Okay, local to the router. Now what does this mean? See, if I am having different autonomous systems over here, suppose if I take example of this, and this is our topology. So what I will do, I'll take the example of this topology only. What I'll say, my all the routers are in different autonomous system. All the routers are in different autonomous system. Okay, now I want to exit from this router. From R1, I want to exit. Okay, now how I can exit? If I want to reach anywhere, how I can exit? I can exit via this way, or I can exit via this way. My basic plan has been expired. Okay, so the meeting will be if we have more than 3 participants, then the meeting will end in 40 minutes. Okay, so I have given the request to upgrade the plan. Okay, so in next 9 in a half minutes the meeting will get end. Okay, so I'll share a new link with you people. Now here we have two exit paths. Okay, suppose the weight on this side is equal to 0 and weight on this side is equal to 1000. Okay, so weight on this side is equal to, suppose if I say the AS path information to reach the, suppose here I am having a network 20 dot network. Here I am having a 20 dot network and I want to reach the 20 dot network. So here the weight is 0 and the AS path is this. That if I want to reach, suppose this is my autonomous system 200, this is my autonomous system 100, this is my autonomous system 300, this is my autonomous system 400. Now, if I want to reach this 20 dot network in autonomous system 200, then my AS path information will be like this, comma I. I will get the information in this way, that if you want to reach the 20 dot network, the 20 dot network is advertised and it is originating from 200. But if I choose this path, what will be my AS path information? AS path information will be 400, comma 300, comma 200, comma I. Correct? If I am going via this path, this route is my best route, but I am preferring this route. This is my preferred route. I want that if anything I want to send to the 20 dot network, I prefer to send it via this route, via R4. Okay, so if we don't have the AS path information, suppose if you don't have the weight information, if you don't change the weight, then it will choose this path. This is my best path, correct? But if we have a weight attribute, it will not see the AS path. It will select the weight first. First, it will see the weight. Now the weight is, path with the highest weight is more desirable, as I told you. So this is my preferred route. So if I increase the weight of any path, then that will become my best route. Understood? Getting me? Hello?
Yes, getting.
Okay. So weight is something your attribute, Cisco's attribute that tells how to exit the autonomous system. It tells how to exit the autonomous system. Okay. And it will be always local to the router. Local to the router means, suppose in this autonomous system, I am having different routers. Suppose this router is connected to this. I am having one more router connected to this. Now, if I change, suppose these routers are also connected with this autonomous system. Okay, now if I change anything on this router, okay, if I change anything on this R1 router, it will be on this router only. Okay, means only this router will select this path. Other routers will still go with the best path only. Understood? Getting me?
Yeah, I have a question here. Uh,
Mm-hmm.
in case if we have two paths and both path having same weight and same AS numbers, then in that case, BGP will have load balance, will do the load balance or not?
We have different scenarios. We'll see what are the scenarios, what can be the, how it will select the path. Okay, if we have the first thing, what it will look, then the second thing, then the third thing, then the fourth thing, we will see step by step. how BGP selects the path. Okay. We'll see in the further lecture, don't worry. I'll explain you that thing also. Now, whenever you will have learned routes, any learned routes will have the weight as 0, and locally injected routes will have the weight as 32768. Locally injected routes. Okay, for locally injected routes, the weight will be 32768, and for any learned routes, the default weight will be 0. Understood? Hello?
Yes, listening.
Okay. Now we can use this weight with the help of route maps also. Okay, we can change the weight with the help of route maps also. Like what we have seen in the route maps, we have created a route map, and what we said we created an access list, and we said for all this for all this network, what we will do, we'll create a route map and we'll match the IP address and we'll set the weight for all the network in the access list as something, whatever we want. Okay, so we can do that thing also. Now let us see, we'll configure some BGP configuration over here. So what I will do, I'll make some plan over here. This is my, suppose, autonomous system 500. Let it be.
I think this is doable. You can give me as a task, not an issue. In last section class, I think you have explained how to modify OSPF,
Mhm.
OSPF
Yeah,
cost
but
using route map.
here I'm showing you the weight attribute.
Yeah, it will be same, like right? Set weight and the value, right?
Yes, yes, it will be the same. So, okay, if you want it as task, then I can give you a task also. So this will be 600. Just a second. Now what you need to do over here, you need to configure iBGP and eBGP peering, okay, using this directly connected interfaces. Don't use loopback, use directly connected interface and advertise all the network as per your topology. You have the topology with you. As per the topology, advertise all the networks and make sure that the next hop should be the next router address. What you have to make sure, the next stop should be the, so whatever task we have done till now to change the next stop behavior of BGP, then here if I see, so till here you can do, right? Till here you can do, but I need to show you about the weight attribute. Okay, I'm not showing you about the route maps or anything. I need to show you about how to how to use the preferred weight, how to set the weight value. Okay, how you can set the weight value. Understood? So